Hey everybody, good morning, good evening, wherever you are. Can you able to hear me? Can you please confirm? Okay, so let's go and begin the webinar today. So today webinar is all about understanding how to do basically bulk uploading with MapReduce. So basically we'll be going over understanding some of the fundamentals of MapReduce and what Hadoop does and also how the bulk uploading works with MapReduce. So myself, this is Sagar and I'll be going over the webinar today. So myself, I have some around more than decade years of experience in enterprise architect, and prior to this, I'm also with big data for almost 5 years now with Hadoop and other technologies. And I'm with Edureka for almost a year on the training perspective. And this particular session is coming you from Edureka, so I think most of you will be aware of what Edureka is all about. So basically, it's an online training platform which provides a 24/7 support and live demo and live classes. So that's what we do, and we have a lot of courses. So please, you can always look back about Edureka at our particular website. So today's session will be focusing heavily on understanding, as I said, the yarn, how the yarn is going to work, and also at the end of the session we have a demo by executing how to perform the bulk uploading with MapReduce. So let's go and jump and have a quick introduction of what basically MapReduce is all about and why we require MapReduce. So MapReduce is one of the one of the fundamental algorithms in the big data domain today. Fine. So let me take up an online diagram tool so that you can understand it better how the MapReduce is basically going to work. Okay. So that you get a better picture of what MapReduce is all about, and also you'll get an understanding of what yarn does over the MapReduce. So MapReduce is one of the algorithm which is not specific to Hadoop or big data, right? There's no such thing like a MapReduce exists only for Hadoop. Okay, MapReduce is basically a fundamental max kind of algorithm which actually started using for Hadoop and in Hadoop to a very great extent. So basically, what MapReduce says is that. So I'm just sharing a notepad. Okay. So what is the idea behind a MapReduce is? So for instance, let's consider an a typical word count application so that you can understand how basically MapReduce works. So whenever you have something like hello, how are you? So when I have a statement something like this, and when somebody steps up and asks, can we able to find or write an algorithm where it is going to end up by explaining how many times each of the word repeated. So for example, in this instance, we can say how has repeated twice, right? Maybe we can say is this repeated twice, right? Likewise, you have to find each and every word just to understand how many times each and every word is repeated in the context of the application. So this is maybe in a span of 10 to 15 lines is fine, but if you look at the very real-time scenario, or if you look at the very real-time contract, so what happens is we'll be dealing with 1 TB or 2 TBs of data, right? Because that's what big data is all about. We generally deal with 5 TBs to 10 TBs of data at a given short of time, where the data is parallelly distributed under Hadoop. So if that's the case, how much smartly this kind of word count can be done? So that's what MapReduce steps up. So MapReduce comes up in a two-way process. One is called as a mapper, and another one is called as a reducer. So a mapper is a process which is going to run completely in parallel. So you can have any number of mapper, right? So the data will be equally split into the mappers. So let's consider, for instance, I'm taking, if you have a let's consider you have 500 MB of data, right? So what Hadoop technically says, split the data on a scale of 128 MB. So if that's the case, so in our particular scenario, we require almost 4 sections of data to be handled, correct? In our scenario, we typically end up say, okay, we require 4 sections of data because one mapper can handle 128 MB of data. So let's split up all this 128 MB of data. So to handle a 500 MB of data, I require 4 mappers, right? So typically what happens with the help of the Hadoop's distribution, I am able to run the data absolutely in a very parallel format. Okay, so you have 4 mappers and basically you end up, so it irrespective of whatever may be the size of the data, let it be a 1 TB or a 2 TB or a 3 TB, you can typically run any number of mappers in parallel by splitting the data on a scale of 128 MB. The 128 MB is somewhat what Hadoop suggests on the scale of how the data has to be separated. So once the data got separated and multiple mappers starts running in parallel, the code will be executed the same in all mappers. There won't be any different codes, right? So if you have the same code will be it's made sure it's get executed in different mappers. Okay, there is no such thing like each and every mapper have their own code. Okay, so now let's consider code. So the code is something where the algorithm steps in. So we need an algorithm basically which needs to find how many number of times the words are repeated by themselves, right? So what it does, let's take an hello, how are you, and how is weather, and is weather fine. So if this is the input data, it takes one line at a time. So it takes one line at a time and it tries to split each and every line into a key and value pair. So let's consider I'm splitting everything by space. So I get keys like hello, how, or, and you. If I split by space, right? Then technically it will ask what is the value. The value I will say as 1. Okay, you can write anything as a value, but in my scenario, I am telling the value as 1. The same thing goes with the other areas also. Let's see how is weather. So basically what happens, it again splits up. It says how is weather. So it says how comma 1 is comma 1 and weather comma 1. So this process it will run parallelly across all the mappers. It's not 1 or 2 mappers. This will run across parallelly all the mappers. So technically what the mapper suggests, whenever you get an input file, basically decide from your side what is the key and what is the value. The logic can be of anything. So in my scenario, the logic is typically is something which just says split by space. Okay, you can write any logic you want, but as a mapper and reducer algorithm, what is technically important or what is the most critically important is you for each and every line you get, you have to output a key and a value. It's fine. So once it does, what happens in the reducer phase, the outputs are all collected and grouped. So what happens? It says hello comma 1, how comma 1, r comma 1. All the values are collected and grouped, etc. Everything happens. So now, even before going to the reducer, what the framework is going to do is just going to collect all the output. Fair enough. Then it's going to sort the output. So when it says it sort the output, it becomes r comma 1, how comma 1, how comma 1, all right, r comma 1, how comma 1, and how comma 1. Then hello comma 1, so we technically see r comma 1, how comma 1, and how comma 1, and hello comma 1. So what are the pending is? The pending is comma 1. The weather comma 1 and u comma 1. Then it shuffles. So shuffles means it tries to bring everything into one way. So for example, it says r is having value 1, whereas how got 2 values. The values of how is 1 comma 1 and Hello is basically having one value. This is basically having one value. The weather is basically having one value. Finally, you assign one value, right? So this what comes to the reducer, and the reducer will again, I'm going to write a code in the reducer like keep the key as it is and do a sum of all the values. So what happens basically, keep the key as it is and do a sum of all values. Keep the key as it is, do a sum of all values. Keep the key as it is, do a sum. Likewise goes for other things. So this typically, once the MapReduce algorithm executes by itself, so it says from the given context of the scenario, I am able to find how has repeated 2 times and how has repeated 1 times, right? So that's how basically the MapReduce algorithm works. So the intention behind the MapReduce algorithm is very clear and very straightforward, is that the mappers and the reducers will always run in parallel. So we have to basically define what is the key and value pair we expect to get from the mapper and what is the key and value pair we expect to get from the reducer. So once you define the key and value pair, so the same code will be applied across parallelly across the systems in a distributed way. Okay, that's how the basic MapReduce algorithm works. Okay. I think you all got an understanding of how the MapReduce algorithm works. Am I right, everybody? Anybody any queries on that? How 4 mappers decided in this case? As I said, Manik, and then the number of mappers basically is decided based on the sections of data, right? So if a sections, if data is of 500, so we say one section of the data is basically 128 MB. Okay, so if you have 1 TB of data, typically you have to divide the 1 TB of data by that number of MB. Okay, yeah, if it's 1 TB of data, you have to basically divide 1 TB by 128 MB. So that defines the number of mappers. Registers is basically of our choice. You can define how many register is something we have to define based on the scale of the application. You can define if you have huge amount of data, so define that many number of registers you want. Okay, a typical scenario we might end up giving only one register. Fine, again. Yeah, so let's move forward to the next level. What is the effective block and split size? As I said, it's 128 MB universe. Okay, it's 128 MB. The block and split size is 128 MB. That's what Hadoop suggests. So the reducer will run only after sorting. Yes, the reducer typically runs only after the sorting and collection mechanism happens. Okay, so whatever we have seen has been pictured in the same way or in the same effect. So when you look back into the diagram which has been shown here, so typically you get a list of values, and after you have to split up into a key of values, and you have to do the sorting and shuffling and etc. Then come to the reducing logic, and from there we are going to produce the final output, right? So this is what basically happens in the case of your the MapReduce algorithm, correct? So now the most important thing is that who executes the MapReduce application. So who's the background behind executing this particular MapReduce application job. So the main person who's going to control this complete the number of mappers and number of reducers is by a person called as Yarn. Okay, I will just go over the Yarn in detail now. So Yarn is something which is going to take a very critical role in running all these mappers and the reducers. Okay, it just says yet another resource negotiator. So the responsibility of a Yarn is to completely control this MapReduce jobs. So how many number of mappers you create and how many number of reducers you create, etc. It's all completely controlled by your Yarn, right? So to get an understanding of how this Yarn works, the typical components of a Yarn, right? Okay. Let me quickly take a question. Sections will replicate in different nodes. In that case, is there any chances two mapper will work on the same section of data? So it will always try to assign one section of data only to one mapper. If you have two sections of the data, then it goes for two mappers. Okay, there is no requirement. If the same section of data, it will work Kiran only if you are submitting the same job again. Otherwise, it will never work again on the same data. Fine. Yeah, fine. So the yarn is very smartly built mechanism. As I said, why it's smartly built mechanism means the yarn in Hadoop 2.0 has been built extremely smartly in such a way that it can support MapReduce. At the same time, it can also support other frameworks. Okay, there's no specific thing it has to support only the MapReduce. So it can support MapReduce, also it can support basically other sections of the data too. Okay, that's one of the important things one has to understand in the case of yarn. So the most important components of the yarn. So when you say the most important components of the yarn are basically the resource manager, load manager, app master, and the containers. So in order to understand better way how yarn works, so what you can consider is a scenario like this, right? So for an instance, let's say there is a branch region head, right? There's a branch region head who's typically going to control all the branches, right? So you have three branches. So you have a branch one, you have a branch two, and typically you're going to also have a branch three. So basically, you have three branches. You have a branch one, you have a branch two, as well as you have a branch three. Okay, existing now. So now each and every branch is typically going to have a branch head, right? So each and everything is typically is going to have a branch head now. Right, so this is a typical life flow cycle of a mechanism. What happens? So that is basically a branch region head, and so this branch region head typically is basically going to handle the three branches, and is basically controlling the three branches, and all the branches is having their corresponding branch head. So now let's consider the branch one at a given point of time started to work on a project, and he recruits a project manager. Okay, so he basically recruits a project manager. So now what happens? And the PM, I'll cut short. I just say PM because I just don't want to mention the complete name. Let's say PM. So now basically what happens in this kind of scenario is the PM is now decided, and to start off the work, he's telling I need 4 developers. Fair enough, you got 4 developers, you can start working on. And after some scale of time down the line in the middle of the development cycle, he feels, okay, I just require maybe 2 more developers. Fine, the branch head provides 2 more developers. Fair enough. At a certain stage of time, he feels now he requires more developers. He's trying to understand the developers who has been assigned for me is not sufficient to complete the particular task which we have to do. So at that point of time, when he goes back to the branch head directly tells him that, so listen, we are done with our resources. It's whatever has been allocated and whatever has been assigned has been given to you with a means whatever we have has been given to you completely. Right? As, we have provided you every single thing. But unfortunately, the project manager is not able to complete the session or the task primarily because still the number of developers is needed more. So at that point of time, what a project manager can do? So project manager typically can do only one thing. He has to start using the developers available in other branches. So to solve this problem, to solve the particular problem in hand, the project manager requires more developers. So what he can do, he can either contact other branch heads and to get free developer what they have. Correct. You just contact them and make sure whoever the developer is free, and you can get them to get a free developer, or Now, this is not scalable. The primary reason why I'm telling this is not scalable, because one of the main reasons to understand why it is not scalable, the primary reason what we can say is that the number of branches can go to any size, right? The number of branches can go to 100, the number of branches can go to 150, the number of branches can go to 200, etc. There is no such restrictions on the number of branches. So the project manager cannot go and request each and every branch manager or the branch heads to give me the developers. So the smartest way here is that the project manager has to contact directly the branch vision head. The branch engineer is completely aware of what's going on in each and every branches. So he can now guide the project manager. You can go to this particular branch called as branch 5 and start taking data from them and start using it. Means whatever the programmers you want, start fetching from them and start using it. Right. So the same way yarn has been decided. That's why the name yarn comes. Yet another resource negotiator. Okay. That's how typically it has come. So what we are trying to say, the same thing when we compare. This kind of flow of architecture is understood for everybody, right? I hope you understand what happens between the branch vision, branch and branch head and the project manager, and with the developers. Okay, a quick yes from everybody. Okay, fine. Yeah. So now, when we compare this with our yarn components, what basically we can do? So who are the players here? The players here are the branch region head, the branch head, the project manager, and the developers. So what our typical application is trying to tell us that the role of the branch regional head should be taken care by a very important person called as resource manager. And so this is a resource manager typically. And the role of the branch head is taken care by the node manager. The role of the PM who is running the complete show at the end is taken care by the app master. And the developers are basically the containers. So this was the basic architecture has been defined inside the yarn. So what yarn is trying to say, you have somebody called resource manager who is totally aware of the things what's going on. Okay, that's the first thing. The resource manager is completely totally aware of the complete things which has been going on. So he is totally aware of which machines are free, which machines are not free, and what is the total number of resources we have, what is the memory, what is the CPU, etc. All the important aspects of the things he is aware of. And node manager will be somebody who is basically available in each and every section of the data, right? So he is the point of contact to the resource manager, and his particular responsibility is to make sure whoever is trying to get, means for an instance, if in a Hadoop system, right, if you have some 3 data nodes, so data nodes is typically the place where the data are stored. So you end up having 3 node managers for each and every data node. So that's what basically it does. So that's what the responsibility of, in fact, even the branch head also doing the same thing, right? The same thing even this guy does, right? So, and basically the project manager is the app master. So app master is somebody who is going to start the work whenever any task has to be done, right? He is basically going to start any job, right? For an instance, if you're trying to calculate the total number of employees per last month, the total number of or the people who is getting the highest gross salary, and these are the jobs, right? And these are basically the jobs which has been assigned. And app master can be anything. So the point what I'm trying to say is that you can run 6 to 7 or 8 to 10 app masters at the same time. You can find you can run a schedule by asking who's the top 10 employee. At the same time, you can also find who are the employees eligible for bonus. You can also find who are the employees are not eligible for bonus. So likewise, basically you can go to any extent or you can go to any level. Okay, you can typically create any number of app masters you want. Now the app masters need to execute the program. So to execute the program, as the project manager requires a developer, the app master requires a containers. A containers is nothing, basically a JVM at the end of the day. just a JVM, it requires to execute some level of statement, right? So if at any point of time, if the containers are not available, or if at any point of time the containers are totally busy, at that point of time, the app master can go back to the resource manager and ask, so please provide me more containers so I can use it. So the intention of coming with this kind of architecture is the primary reason of coming with this kind of architecture. So once the app master is not having the availability of the containers, so you can always go to other data nodes where the containers are available and you can start using it. So that's how basically your yarn has been designed. So that's why it said yarn is a very smart network, right? It's a very smart mechanism which has been built up. So at any point of time, if you submit a particular job, a job in the sense can be anything. A job basically can be like, as I said, a job can be like a very small job to a very huge job. Okay, it might be, and also it may be either a MapReduce job or maybe not a MapReduce job. Okay, typically it will be a MapReduce job. It may not be a MapReduce job too. For instance, there are things like Spark, etc., which is not MapReduce. So at that point of time, Yarn runs as a MapReduce, right? So these are the things. So these are different things. One has to be very clear of what's happening, right? So you can typically basically have the capacity to submit any number of jobs. You can submit any number of jobs at any point of time, and whenever you, so across the cluster, whenever the app master starts to work on the particular thing, it can request the resource manager and get the containers and get the job done. Okay, question from Sridhar. When the additional resources are assigned to other node manager, who will controlling the resource? That's why we have a resource manager, Sridhar. The resources across the cluster is maintained by the resource manager. Resource manager should be totally aware of these things. Yeah. Question, yeah. Spark can't be run by Yarn. No, absolutely wrong statement, Manikandan. As I clearly said, the app master can be a MapReduce job. An app master is a job. Okay, a job in the sense do some level of operation, right? It may be anything. So it may be a MapReduce job. Okay, it may be a MapReduce job, or it might be a MapReduce job, or it might be Yarn job. Sorry, it might be a Spark job. Okay, yeah, or it can be any job. Okay, but the only one thing, the way the clusters are defined will be in a different perspective. The way they are going to run is in a different perspective altogether. The way the internal components are going to run on altogether. Okay, you have to configure Yarn in a very different way, right? When you want to work in Spark, but typically Yarn can run on Spark at a given point of time. The app master can be MapReduce job, or it can be any job. Okay, so that is very much your understand. Okay, yeah. Is there any limit for resource manager to handle the number of? No, there is no limit, Srinivas. The primary reason why there is no limit, because this is a cluster. You can scale up to any level. You can keep adding how many number of. You can keep adding the machines in your cluster. So there's no specific thing like there is a limitation. So what happens if the resource manager does not find any containers? A good question, Rajesh. Typically, resource manager has a built-in scheduler. So if all the containers are full, yes, and a very rare scenario, let's consider all the containers are full and it's not able to get any container at all, then there is no other option. You have to typically halt yourself in the scheduler for some period of time. You cannot come out and you have to wait in the scheduler. So once the scheduler frees up some of the containers, and then only you can come out of them. So until that time, you have to wait in the scheduler. There's no other option. Fine, Rajesh? Yeah, it has a scheduler smartly. So when you look at the flow of the mechanism, so basically what happens, we have a nice diagram which explains the flow of the mechanism. I just show you up. So this particular diagram which shows basically the flow of the diagram, what happens. If you look back into, right, the client contacts the resource manager. The resource manager triggers the corresponding job it has to start, and he just registers and he speaks to the node manager. And after that, what happens, application master starts working on to launch the containers, and application code is executed in the container. When you say the code, it's just a MapReduce code. Okay, And also the client can contact at any point of time the resource manager or the application master to monitor the application status. Okay, there's no specific thing like that. The client can basically contact at any point of time. Okay, basically the resource manager as well as the app master to know what is the status of the job. So there's a very nice sequence flow of diagram which basically says what happens typically in the case of your resource manager cycle. But as I said, the name negotiator comes up in the picture because the app masters can negotiate themselves very much smartly across the cluster of the containers. So at any point of time they want containers, they can start using and anything. And also the containers is not specific to one particular operation. So it's not like they will run only MapReduce job. They might run a MapReduce job or a Spark job or a message kind of job. It's maybe anything. Okay. Typically, it will be MapReduce because most of the applications are MapReduce. But Spark is something which is getting extremely popular these days, and Spark is having its own cluster too. But at the same time, Spark can also run on top of Yarn. Okay, so that's how basically the Yarn basically steps up between your things, right? Fine. So maybe I just go over one thing called as a bulk load before going to this, and that's what the demo of session we are going to look into. So before going to the bulk load, means as I said, it's just 1 hour of session. I just try to summarize in a very brief way of how the MapReduce works and the particular job of MapReduce, how basically your Yarn takes control and starts running on. So typically there are basically two components exist here. One is the HDFS, typically where the storage does, and one is the Yarn where basically the job runs against the data in HDFS. So the data gets stored in HDFS by splits, by blocks, and etc. All those kind of things. Once the data gets stored in HDFS, so we basically have another component called Yarn, which can execute the job. Okay. Parallelly at the same time, as I said, that's why I keep repeating. There is no such like only one app master. You can trigger any number of app masters you want. And at any point of time, when app masters are not sufficient enough to continue further, they have to either wait in the scheduler because they don't have containers, or they can reuse the containers across every single point of time. Okay, so this is a basically brief idea of how Yarn and the MapReduce works on top of it. Yes, obviously, when you join the course, we'll be going to the each and every component inside the Yarn in detail and inside the HDFS in detail, and typically we'll be going across each and everything in details when you join a particular course, right? So in today's session, we actually don't want to show you the word count example because it's something which is one of the basics examples in the MapReduce. So what we plan to show you something is called as a bulk upload using MapReduce. So we can just to tell you that you can also do a huge bulk upload with the help of your MapReduce operation. Okay, this is just to tell you that how much effectively a bulk upload can be done with the help of the MapReduce operation. I'll be just going over the code and I'll be executing some of the commands, but some commands might take a huge amount of time to run. So I might show you the pre-configured output for that. Okay. So any queries so far before even stepping into the example? So on the brief, means as I said, I not went to the each and every layer of Yarn. The primary reason is I want to make sure to summarize how Yarn works and provide a summation of how MapReduce works. Okay. So if you have any questions, you can ask for 2 minutes of time, then we can go to the bulk upload program. I see a lot of participants joined after the initial startup, so maybe I think you might have got the point of how basically Yarn works and as well as how the HDFS works. Okay, fine. So typical in this particular application called as a bulk upload, what we are going to see is basically understanding of how data can be pushed into a bulk in Hbase, right? So Hbase, as the name suggests, is one of NoSQL databases. Okay. Did you all at some point of time come across a NoSQL database, right? Okay. What's the difference between primary name node and the secondary name node? Oh, that's basically an Hadoop question, which has the difference between primary name. There is no such thing called primary name node and secondary. There's something called name node and secondary. There's no such there's nothing called as primary and all. A name node is something which is going to keep on continuously serve the clients. By secondary name node is just a backup node which can be used when the name node is down. Okay, that's the difference between the name node and secondary node. Okay. Okay, situations where yarn performance degrades. Okay. And so there is no such situation like the yarn performance degrades. Yarn is something a cluster. There is nothing like yarn is nothing to do with the performance. If you have a very good cluster with a very good RAM with the most number of means all the process etc., yarn is going to be faster. But what you're going to run on top of yarn is going to make your application faster or not faster. Okay, so that's what basically decides the complete application. So if you are basically running a MapReduce on top of yarn and a Spark on top of yarn, you'll find a contrast difference because the way the Spark works is different and the way the yarn works is different. So it means the way how the MapReduce on yarn works is different, and how the Spark works on yarn is different. The Spark completely works on the in-memory. So basically, it's just a completely in-memory kind of thing where it runs extremely faster on yarn. Whereas a MapReduce is something like an iterative algorithm where each and every output will be written to the disk and taken from the disk, right? So the technology which you run on yarn is going to basically define the performance. Yarn as such is not having any performance issue, primarily because yarn is a cluster, which is built up of like a machine's RAM and process, etc. Fine. Financial. Got the point, right? So what you run on top of yarn is basically going to define your performance. Not yarn is not going to define your performance. MapReduce job will write in Java. What about Spark jobs? Spark jobs can be written in Java, Kiran. Typically, it's written in Scala, but you can write in Java too. Spark jobs can be written in Java too. Okay, but typically they will be working on Scala. So going back to the example, what we have basically, I'm just going to show you an demo of how to bulk upload data into Hbase. So Hbase is one of the NoSQL databases. Okay, and NoSQL databases are another important thing in the market today because again they can distribute the data. NoSQL databases again can distribute data. So whenever I say, whenever we say distributed data, so whenever we say distributed, in the sense what we are trying to say is that things like the NoSQLs compared to an RDBMS, they can produce an horizontal scalability. So an horizontal scalability is something means where you typically can have multiple number of systems running horizontally at the same time, right? Whereas a typical RDBMS is something which is a vertical scalability where you have to keep on improve the performance in that particular machine. Right, so that's what the typical difference between your NoSQL and SQL database. And also in SQL kind of database, the schema is fixed in most of the scenarios. If you want to add a column to an existing table, there are a lot of things we have to consider, whether the added column is going to affect the already existing data, or the added column is going to create some data, means some issues with the data which is already existing. So we have to consider all these kind of things. Whereas a NoSQL database is something you can change the schema on the fly. There is no such specific impact will happen on the data which is existing. So that's why the NoSQL databases are used widely in the market today. And one of the best NoSQL databases, it's Hbase. Probably yes, MongoDB is also there. The primary reason of Hbase because Hbase has been built on top of Hadoop. Hbase is built on top of Hadoop. So if you want to work with Hadoop specifically, Hbase is the best choice because Hbase is something which continuously runs on top of Hadoop and which can make the data persistence in Hadoop in a very seemingly easy way. Okay, because it has been built specifically to work with Hadoop. Right. So that's the reason. Okay. How can you relate cluster with relational databases? So totally both are two different scenarios, Anshu, because a cluster is something which is highly scalable. You can basically add any number of machines you want to the cluster, right? There is no such restriction like you can't add more machines to the cluster. There is no such restrictions. You can keep on a 40, 50, maybe a 90 or 100 machines to the cluster. It's up to you to add any number of things. Whereas RDBMS is something is not suitable for big data kind of technologies because those are vertical scalability. You have to keep finding the solution on that particular machine itself. Okay, so that's the primary reason coming up with cluster. Cluster is basically going to have a huge amount of scalability of data where you can store data to any extent because it's going to run everything in a parallel distributed mode, right? And RDBMS can't do that. So that's the primary reason. How is Hbase different from MongoDB and Cassandra? Okay, as I said, in a NoSQL perspective, there is no major difference because they are all going to have their own way of defining the data, right? The primary intention is to make sure they have a variable schema. So in Hbase is something why it is different because Hbase has been built to work with Hadoop specifically. So if, for instance, if you use Hadoop, if you use Hbase along with Hadoop, Hbase knows how smartly to save the data, right? Hbase saves the data in the format of something called as an H file. So basically, what happens? An H file is a one which can be saved inside the data node very much effectively, and it's so much tightly coupled with Hadoop's cluster mechanism. Whereas MongoDB and Cassandra are not, they are not part of the Hadoop, and they have their own definition and they have their own systems. Okay, so that is completely different, and each have their own way of usages. Okay, yeah, fine. So I'll just quickly show you the example of what we have planned for a. Yeah, so I just open the VM. As I said, I can't run the. If I run it, it's going to run for some period of time. So I have already ran the example. So I'll just show you how basically it comes up. So typically, if you look at this particular program, right? So whatever has been shared here. So this is a particular program which is designed to load a huge amount of data into your Hbase in one shot. So what it basically does is that based on the MapReduce code and MapReduce algorithm, right? Hbase is assigned corresponding MapReduce code and MapReduce algorithm. So what basically we are trying to do is that we basically use, first of all, the bulk upload is something which is already part of Hbase itself. Okay, it's not something we are going to write. Bulk upload is a tool which is already available with Hbase, so one never needs to worry about that. Okay, so what a bulk upload requires, basically the bulk upload tool which is part of the which is part of your Hbase requires an H file. So we basically need to write a MapReduce code which can generate an H file first. Okay, an H file is something which can be used very much effectively under your Hbase kind of scenarios. So this is the one which basically takes the crime data. Okay, so let me show you the data, and I'll show you how the H file has been generated from that. Let me open the cluster. So if you look back, so this is the particular data which has been available inside my HDFS after a lot of MapReduce code. It's a typical MapReduce code of a data where it's having a criminal use case document which says what is the type of the use case and whether the person who has been registered with the case or not, whether he got an accident, or what type of all the related things will be available in this particular kind of things. Okay, it's a completely crime related case, so it just been taken from the and US website. So now what happens, basically we are going to run a bulk loader conversion into H file kind of combination. So if you see what happens, in order to load in a very bulk data into the Hbase, so we have some kind of format called as an H file. So an H file, I just show you how an H file looks. I'm just opening it up, so it's just a sequence file. It takes some time. Okay, so I'll just run the code to get the data and dump it to the Hbase with the help of the H file mechanism. Okay, as I said, it takes some amount of time, so I'll just show you the final section of the data. Okay, so if you look back into my Hbase, so I'm just opening up the Hbase now. I just ran the code, so you can see how much data has been dumped into my Hbase in a very bulk shot. We'll share this code, so don't worry, we'll also share the steps of how can you do, because if I start executing, it takes some 10 minutes for me, so which might which might end up which might end up a lot of wastage of time. So if I say list, and I'll just show you the table of the data, means whatever the crime file has been shown, which has been converted to H file. So you can see that how much amount of data has been loaded in one shot. So this is the amount of the huge amount of data has been loaded in bulk in one shot from the MapReduce into H file to Hbase. All right. Right, so we just so the section of the code is basically what it does. It's just having an Hbase MapReduce code, which basically reads the data which tries to convert from the crime.met file into an H file, and with help of bulk uploader tool, we are basically trying to load the complete data from H file into Hbase in one shot. So you can just see, right, it just keeps going on. These are all uploaded in one shot. This is a huge amount of data which has been uploaded in one shot with help of your Hbase bulk upload tool. So the bulk upload tool Hbase is having. So basically, whenever you write a MapReduce code, so what you have to make sure is that if you are in a position to convert them into an H file, and you can do a very huge amount of bulk upload into H file into Hbase in a very fast and in a very fast approach, right? So it's going to keep going. There's no stoppage for this. So this much amount of data is going, okay. If any wrong data within the bulk upload and how we find it. So that's where you have to smartly handle the code, Richard, because as I said, the H file has been generated with your code. Okay, the bulk upload tool just taking the H file and uploading. So while generating the H file, take care of all the operations like the data wrong, etc., all those kind of things. Fine, Richard? Got it, right? Because the generation of H file is in your hands. So generating the H file, so you got one input file. From that input file, you generated the H file. The H file only is uploaded into the Hbase. So while generating the H file, consider all your scenarios in the code, all the exception scenarios, etc. So that the filtering, everything should happen in that point of scenario. And yeah, fine. So first we need to convert and load into HDFS. Yes, reverse. Yeah. So first you do any level of MapReduce codes and convert into H file, and from the H file you have to upload it. How many records will be loaded per second? It completely depends on your cluster performance, Swapna. Completely depends on your cluster performance. It depends on the RAM. So I just stopped this because this guy will never stop all of this. Completely depends on your cluster performance, and with a very typical good cluster of a 16 GB RAM, the thing should happen in the span of milliseconds. Swapna. It should happen in milliseconds itself. Can Hbase be used for sentiment analysis? Yes, you can do it, Shubhajit. So sentiment analysis is something which is basically you are taking the data and see, this is what basically we are trying to say. You write a MapReduce codes and do all your analysis, and you have to store the analysis data, right? So what we are basically trying to say is that once you got the complete analysis of the data, okay, convert them into an H file and bulk load into an Hbase. But all those the sentiment analysis is something which is a MapReduce code which has to be done even before converting them into an H file. Right? Hbase is just a storage which is going to happen. H file is just the easiest way of dumping your data into the Hbase. Correct? Fine, Manish? How much memory allocation? No, Hbase is just a part of your Hadoop cluster itself, so that takes care of it, Richard. So we don't need to worry about that. Okay? So never worry about that. Can Hbase serve data for a website? See, the data, what we have to do is that, as I can't show any example now, Niranjan, typically I can show the example as part of the course. So what we do in a real-time scenario is we try to convert the data from Hbase into a Hive. So Hive can basically give the data in the SQL format. So once the data comes in SQL format, basically you can load the data into website or anywhere you want. Okay, so that's all you have to do. You have to find a way out how the data in Hbase can be loaded into Hive, etc. All those kind of things. I mean, every company does the same thing. They does the same thing. They will load the data into Hbase and they'll convert it into Hive because Hive provides a SQL statement. Fine. That's the best approach they can do. Okay. So local file MapReduce generate H file, store in HDFS, load from HDFS to Hbase. Exactly, Srinivas. H file still exists in HDFS. If you want, keep it, or you can just trash it up if you want. Can you show how you define the column families for data in a map job? Okay, sure, definitely, Richa. Oh, sorry, definitely, Kiran. So I think you can see the code, right? Basically, we define the corresponding column family and the column qualifier, and we'll pass it to the mapper. Fine, Kiran. What tool can we use for converting data from H file to I? No. There is no tool you can convert data from H file to I. Load the data from H file to Hbase. Hbase to Hive you can directly convert. Hive can directly understand the data from Hbase. Fine, Shubhajit. Yes, all the code and everything will be shared to you all. Don't worry about that. Is there any difference between HBase and CouchDB? As I said, Rich, I will tell only one thing. There is no, please don't compare HBase with other database, other NoSQL DBs, because HBase has been built only to work with Hadoop very much effectively. So if you're working with Hadoop, the best approach is HBase. Okay, there is no other specific reasons under which is faster. Fine, Risha. So code runs on Hadoop 1.2.1 as well or only on Hadoop 2.0. It runs on both Srinivas, but most of the latest of Hadoop versions, means most of the latest of Hbase version supports only Hadoop 2.0. So I'm not sure on how much backward compatibility will be supported, but if you are decided to go ahead and change the rate ratio, then you have to make sure you're using the latest Hadoop 2.0 version. How to generate a row key in Hbase? What is it? The row key should be always unique. The best approach is to add the timestamp to it, Srinivas. Have the row key with the timestamp. Whichever the time you are trying to insert, add the timestamp along with it. How is the row key deflection done? How we defined? Yes. I'm just defining the key H key that set ID here, right? So I'm just taking the field which is part of the previous HTFS input format and setting the ID here. So once you look into the code, you'll easily understand that. What products are available in market which competes with Hbase? So there's nothing like, as I said, Shubhajit, with Hadoop, Hbase is the best option. A lot of other things that are coming up, like Spark SQL is something which is coming up, which is not matured enough, but it's coming up to a very great extent. So Spark SQL is something which is now coming to a very good effect actually. Okay. Can HBase replace RDBMS? Yes, definitely, Srinivas. Yes, definitely it can. How quick Hbase will retrieve data compared to RDBMS? Actually, you should not compare to universe because RDBMS cannot be faster. It is a single scalable machine. Whereas Hbase runs on a cluster on a huge number of machines. So it will be extremely highly scalable. Fine. So any other questions from anybody? So all the PDFs and the code and etc. everything will be shared to you all. You can just go over it and you can just contact the support at any point of time. And it will be nice if you all going to. Yeah, thank you, Srinivas. So it will be nice if you all join the course where you can get a better understanding of technically on Hadoop and also the Hbase, etc. And you can always contact the support for the course details. And can you explain some other? I think the best can be done solo apology. I think in if I mean as a very span of time, I can't go ahead further. But when you join part of the course, we'll be giving provided the use cases under solo apology. Fine. We'll put in a nice use case regarding the same solo apology. Okay. Because in a short span of time, we can't proceed further. Yeah, fine. Thank you all, and please fill the feedback at the end of the session and try to join the course. Okay, the course will be a very good one, and there's a lot of discounts will be available for the course. Right. Thank you very much, everybody. And the code, the video, and the session, everything will be shared to you all in just a matter of time. Thank you. Thank you very much. Please fill the feedback at the end of the session. Thank you, everybody.